Let's talk about a mystery that's happening inside you every single second of your life. It's a hidden superpower, really, one that keeps your entire world from just dissolving into a shaky, chaotic mess. So, what is it? Seriously, try it right now. Just turn your head from side to side. Notice how your vision stays stable. Why isn't the whole world a blurry, unwatchable mess, like a shaky cam video? Well, the reason we don't live in a constant state of motion blur is all thanks to one of the most elegant and fastest reflexes in the entire human body. Okay, so first up, the unshakable view. We're about to meet the hero of our story, a little biological marvel that's working tirelessly in the background just to give you that stable, clear view of the world. Okay, so here it is. It's called the vestibulo-ocular reflex, or just VOR for short. Now, think of this as your brain's own built-in biological image stabilizer. It's constantly sensing your head's motion and instantly, without you thinking about it, commands your eyes to move in the opposite direction. And this keeps whatever you're looking at perfectly locked in place on your retina.
I mean, it's just this perfect, instantaneous counterbalance. Your head turns one way and boom, your eyes rotate the exact opposite way at the exact same speed. It's this simple, elegant action that stops the world from blurring into absolute chaos with every tiny movement you make.
And here's what's truly mind-blowing. This reflex is so deep-wired that the VOR doesn't even need your eyes to see a thing for it to work. Nope, it's all based on your inner ear's sense of motion. You could be in a pitch-black room, eyes shut, and this reflex would still be firing perfectly, ready to stabilize an image that isn't even there. Okay, section 2, a lightning-fast pathway. So how in the world does your body pull off this incredible high-speed trick? To get that, we need to look at the body's secret for high-speed communication. It's like a neural superhighway. Well, the secret is this ridiculously short neural circuit. They call it the 3-neuron arc. It's so simple, it's brilliant. Step 1, sensors in your inner ear detect your head's rotation. Step 2, that signal zips through a nerve directly to your brainstem. And step 3, the brainstem immediately fires off a command to your eye muscles. That's it. It is one of the shortest, most direct processing paths in your entire nervous system. And because that pathway is so short, the speed is just mind-boggling. The whole thing, from the moment your head moves to your body's compensating, takes less than 10 milliseconds. Now, to put that in perspective, a single blink of an eye takes over 100 milliseconds. This makes the VOR one of the fastest reflexes in your body. And it absolutely has to be, right? Whether you're an ancient ancestor tracking prey or just you walking down the street. But you know, speed is only half the battle. This thing has to be perfectly calibrated too. In science, this is measured by something called VOR gain. All it means is that if your head moves 10 degrees, your eyes have to move exactly 10 degrees back. The ideal gain is a perfect 1-to-1 ratio, or 1.0, and that's what gives you that perfectly stable image. So what happens if that calibration gets a little wonky? Well, this is where it gets really cool. Your brain can actually learn and adapt. Think about when you get a new pair of glasses. The world might seem a little off or swimmy at first because the magnification's different. Your brain detects that tiny visual error and uses what's called motor learning to slowly recalibrate the VOR game over a few hours or days until your vision feels stable and normal again. And get this? There's another amazing layer to all of this. You can actually turn it off on purpose. If you want to follow, say, a bird flying across the sky, you need your eyes and your head to move together, not opposite each other. Your brain gets this. It actively suppresses the VOR reflex, which lets you track the object smoothly. It's a pretty remarkable example of your conscious mind overriding a powerful, lightning-fast reflex. So on to section 3, when the system fails. Because, no system is foolproof. And there's a really common situation that throws this whole precise mechanism into total chaos, a disruption that I'm willing to bet many of us have experienced. Yep, you guessed it. Ever had the spins after maybe a few too many drinks? Well, that is your VOR system being chemically sabotaged. It's a perfect, even if it's an unpleasant, demonstration of what happens when this amazing system gets fed bad data. Okay, so let's zoom in and see what's actually happening on a microscopic level. Deep inside your inner ear's balance canals, you have this little gelatinate-like sensor called the cupula. It's surrounded by a fluid called the endolymph.
Now, what's really important is that they normally have the exact same density, so the cupola just kind of floats there neutrally, not sending any signals. But when you have a drink, alcohol, ethanol, it sneaks from your bloodstream into your inner ear. And here's the kicker. It gets into that cupula sensor faster than it gets into the fluid around it, just because the sensor has a better blood supply. This makes the cupula temporarily less dense. Basically, it gets lighter than the fluid it's floating in.
So now, this sensor is basically buoyant. It starts to float. And that little movement sends this massive false alarm straight to your brain. The signal it sends is identical to the one for actual, real spinning. So your brain, completely fooled, genuinely believes you are in motion, even if you are lying perfectly still in bed. So what does your brain do? It thinks you're spinning out of control. So it does its job. It fires up the VOR to try and fix it. It commands your eyes to move in the opposite direction to stabilize your gaze. But since you aren't really moving, your eyes just drift to one side and then quickly snap back. This involuntary jerky eye movement has a name. It's called nystagmus, and it is the direct cause of that horrible room spinning sensation. All right, our last section, why this reflex matters. Because this isn't just about explaining a hangover. The sheer reliability of the VOR is what makes it so incredibly important in medicine. Because it's such a fundamental, hardwired system, it's become a really powerful diagnostic tool. You know, doctors can test the VOR really easily right at a patient's bedside to check for damage to the inner ear. But its importance goes way, way further. That VOR pathway runs directly through the brainstem, the most fundamental part of the brain. And because of that, testing for this reflex is a critical, mandatory step in confirming brainstem death. Its presence or its absence tells doctors something profound about the brain's most basic ability to function. So there you have it, the vestibulo-ocular reflex. It's this constant, invisible superpower working tirelessly every second to grant you a clear and stable view of the world. It's a truly beautiful piece of biological engineering. And it really makes you wonder, right? What other incredible systems are humming away inside of you at this very moment, quietly making your entire experience of reality even possible?